So let's do the next challenge, which is subtracting 96-bit operand 3 integer from the sum. So we now have the sum computed, and the next step is to take this sum and subtract something that looks like 3 duplications of decimal 2 in memory. So this is what gets stored here, but basically what just to make it clear, I want to show you that this bit pattern that we store in operand 3 looks like this, and let's just, I guess I'll just expand everything so we can match every byte, like byte to byte. And here there are 3 more in front, like this. Okay, so this is what needs to happen. So this we need to be able to take this sum, which we already have in memory, and subtract this value, this hexadecimal encoding of a number from it. So the operation here will be to subtract this, right? So this minus this. So that's the idea. So let's see what we can do to do this work. So we can write another comment about this and just specify that this is the second part of our assignment right here. Just align everything. So subtract two 96 numbers and store the result as a 96-bit difference, the result of subtraction. So these are the steps I think that we can use here. Okay. So once again, I'll try to split this screen to keep our bit patterns in view. So this is the sum, and this is the operand 3, and this is the solution that we're trying to work through. So let's take a walk through this solution. Step number 1, we're going to take basically this value, and we're loading into register EAX. And so we're starting with the lower bits. So remember, these are just bit patterns, like if this was a 96-bit size register. Okay, so these lower bits are stored at the location of operand 3 right here at the lowest part. So I guess here, in fact, I apologize, I'm trying to say that I'm trying to grab this lower portion of the operand 3 of this bit pattern. So we load this portion into register EAX, and then we subtract this the value, this value, we subtract it from here, because then we go to the sum plus offset 0, which is the lower part of this sum, and we subtract. So we do just regular subtract, and now we should have our result in place directly in this location. So this memory will be updated with the result of this subtraction. Basically, take this minus 2. This should look like 76BB 5734, because we're subtracting 2. Next step, we start working with middle bits. So what we do with middle bits, which we're loading the middle bits, these bits, right, this portion, again into register EAX, and again we're subtracting in place from this portion over here. The only trick is that we're also subtracting with borrow, because if we had to borrow from here, the carry flag will contain the indication that we had to borrow, and this borrow will also be subtracted from here. So we subtract basically this value minus 2, which should be like this thing 0, 4, -2, minus carry flag, and I don't expect carry flag to be set here, so it should be 0, 4 in here. And we're of course updating it in place because we're updating the middle portion of the sum. And finally, we're going to proceed to update this portion over here and subtract this from here, but again subtract with borrow, and the outcome should be the result of this, and there should be updated result of this value in computer memory. So let's take a look. Once again, I'm just going to I can set a breakpoint right here and step through these things. So let's go through. Let's start. First of all, we need to build this. Okay, so this gets built, and then we're just going to run debugging. Debug, start debugging. So once we start debugging, we set breakpoint and we stop right here. So let's right away take a look at the content of sum. So that should be already pretty recognizable because above here all the code has already been executed. So now we have we should have this recognizable bit pattern in little Indian storage order. So again, let's go to view, immediate window, and I'll just clear it and type it again, question mark space ampersand sum. Okay, so the symbol is recognized, and immediate window gives me address of the sum in memory. We switch to memory view and we copy and paste this address, hit enter, and so this is pretty much the result that we had before, and we begin our subtraction. So let's watch how this portion of the storage is going to be updated. So I'm going to press F10. Now we're just about to do the subtraction, and so here's 34, the value that we're discussing here. This became 34, and this is the lowest byte in our memory. And so now the low portion of the sum has been updated. The carry flag is recorded in the flags register. So we can, we used to have bit masks to check that, but I'm not going to do it right now. So let's go to the next part. So the next part here, F10, F10, and this time this got updated. So just like we discussed, this was 06 minus 02, it became 04. But of course the order of this little Indian storage is reversed. So now this portion of the result has been updated. And finally, these two instructions do the same, so we do a little bit more, and so that makes, of course, the final update right here. So the result is right here. So this is the final result. So these are all FF, because then we had 0, 1 over here, and we subtracted this. So this became a negative number, right? Or it could be a situation with underflow if we treated these numbers as unsigned numbers. So I would encourage you to complete this exercise by copying these bytes, of course, into this result right here. Replace these question marks with this result, and remember that you have to come up with the final value. This will be this right here is in little Indian storage order, but you need to properly reverse all the bytes to convert the result into something that could be visible if we had been able to load this from memory into a 96-bit register. Just the same thing that I did over here. I'm asking you to complete this exercise with the result. So right here it's all visible on my screen, but I encourage that you save the project, compile and step through this in your debugging session and display the memory, and make this visible, copy from here, paste, do the reversal, and tell me what is the actual hex value of the result in sum is. So what is the resulting sum after subtracting this operand 3, right? So this completes step number B. So this is what we try to do right here. So sum is now equals sum minus operand 3.